This is a session about data and data exploration, right? Your data, your search, Elasticsearch. My name is Costin Leau. I'm an engineer at Elasticsearch, the company. And I'm going to talk to you about Elasticsearch, sort of the product. Now, let's just see if this thing actually... Well, good thing I'm here. So, the agenda for today is pretty straightforward. We have, I'm just now trying to start the timer as well, just to make sure I'm not running over time. I don't want to scare you guys, but yeah, we're going to have quite a bit of stuff to show up. So it's going to, since we have the luxury of additional time, 30 minutes rather than the typical 45, 60 minutes session, I like to not just talk about Elasticsearch in general, but also, do a bit of demos and, place Elasticsearch within sort of the ongoing challenges right now in IT, such as, big data and analytics, that type of stuff. So without further ado, what is Elasticsearch? Well, apparently some of you here know. Just in case you haven't figured that out, at least some parts of it from the name, it's an open source search and analytics engine. It can deal with any type of data, whether it's structured or unstructured, is what we call schemaless. It runs in real time, or what is called near real time. So most of the operations execute within milliseconds. 1 second typically is already slow. It has, as we said, an analytic engine. We have what we call faceting or aggregations, so you can very easily slice and dice data, zoom in and zoom out. And it's also REST-based. These are sort of just some highlights. The interesting part here about the REST-based is it just uses HTTP and REST and JSON. So for the most part, you can talk to it just like you do with any other service, just like you talk to a website. And as you'll see, that's actually quite convenient because it means you can run it, you can use it within whatever platform, application, or environment you have at your disposal. They are really very low requirements. It is distributed. That's something that we, to some degree, not necessarily take pride of, but we're very focused on, meaning that it is designed for the cloud. So as the name implies, it is elastic, so it can very easily scale. It can very easily add machines or remove machines from the cluster. So that's part of the system, part of the job. For the most part, it happens automatically. There are tons of configuration options that you can use, but for the most part, you don't have to do that. And we also have here what we call big data. That's a term that, it's big. It's very hard to define what big is, but I would say it's designed for petabytes of data. So it is designed to cope with data that doesn't fit on one machine, but actually can fit into a cluster. So for the most part, as long as you have hardware to throw at it, Elasticsearch can scale. It is very lightweight. We have the product itself is a jar, actually a zip, around 10 megabytes. If you expand that, you get a folder around 20 megabytes. And it's quite lightweight. There are no dependencies outside the JVM itself. There is a picture made by a colleague of ours, of a cluster made by a colleague of ours. 4 Raspberry Pis running in a cluster that was running Elasticsearch, and that was basically answering queries and doing indexing and that type of stuff. So pretty lightweight. And it's also fairly popular. We started doing a bit of tracking. We get around 200 to 250,000 downloads per month. Just to put things into perspective, Elasticsearch is a relatively young project. It started around 2010, so it has around 3-4 years. And the company itself probably just had, I think, last month or 2 months ago, its first year anniversary. So, with this perspective, 200 to 250,000 downloads per month is quite nice. We also get a lot of questions about the logo. What's up with the logo there? The bonsai, okay, it's cool, but what is it? Well, that's the whole thing about it. A big motto on Elasticsearch is to make it very easy for you to use it. We like Elasticsearch to be the tool that you use to explore data, so it doesn't really get in the way. And the bonsai there, it's sort of our motto. We say it's cool, bonsai cool, in that you just, you don't think about Elasticsearch, you rather think about your data and start exploring it. So you'll see we have a lot of defaults and out-of-the-box experience. We think it's pretty good, and if you have any feedback on how to improve that, would be definitely glad to hear more about that. So what about our users? Well, you have from individual users, small teams that are using it for their POCs or whatever projects they have. those of you here in US are probably familiar with Mr. Harper there. Harper Reid used to be the former CDO of Obama's presidential campaign, the former one. To the typical companies that you see. Again, small startup that are just launching their own product to potentially big corporations, developer sites, whether it's mobile, social, or a typical backend usage, you can use, and they are using Elasticsearch as well. We're also quite happy that we've been mentioned in ThoughtWorks Radar platform. Again, the company is quite young, so the fact that we are a runner-up for this year in platform adoption among the fifth contestant is quite good. But we also have tons of use cases, and I think this is what's most interesting. I guess most of you here have been at the keynote, right? I'll take that as a yes. Probably attended Chris's session again on Spring.io, right? A new website for Spring Framework. I'm actually quite happy that actually this was unveiled. Does a lot of justice, I think, to the goodies that are available within Spring. Well, Spring.io uses Elasticsearch underneath. And if you've been to Chris's presentation about the architecture where they store the pages on GitHub, some of it is cached, some of it is on a static server, all that content on the website is available through Elasticsearch. GitHub, since we mentioned regarding Spring.io, uses Elasticsearch throughout the entire website. So whatever you're using for project names, usernames, issues, or code itself, all the search happens in real time when you click on the website through Elasticsearch as well. They have quite some impressive numbers there, around 20 terabytes of data, 1.3 billion files, 130 billion lines of code. There are also a couple of blogs that you can read if you're interested in that and how are they using it. So you can use it for text search, right? So you're looking for text, you're trying to figure out what type of information you have available within your documents or your source code, right? But also you can use it for things like geolocation, which is what Foursquare uses Elasticsearch for. And again, everything that you see on the website hits Elasticsearch at some point. So you get around 50, 60 million venues per day. And again, that's an increasing number. You can use it for recommendation. This is what StumbleUpon uses Elasticsearch for. Again, very flexible. So it's not necessarily just about finding data, but also finding about the different relationships about the data. Or you can just use it for reporting. And this is sort of a business insight type of thing. This is a product from a customer that relies on Elasticsearch. So it can do intelligent supporting. So for example, when you have an outage, when you have multiple issues being reported, rather than just blindly send that to various support folks that are going to jump on it and at the same time trying to fix it, they can actually figure out that they're all related, try to provide more context and actually just deliver it to one department that can handle that. Logging. A common use case, for some reason, logging seems to be quite an ongoing topic. Every 3-5 years you have logging, whether it's a library or the general use case of your application. Any company nowadays, whether it's big or small, due to the whole emergence of smart phones and CPU devices, everybody more or less is connected to the network. Now every person ends up with having more than one device, and you have a lot of digital footprint, which in turn leads to more generated data. This is what logs are, right? You can probably look at the log, but you don't actually have insight into what's going on. There were several talks here talking about logging and impressing volumes. Well, in the open source, there are several projects out there quite popular how to handle logging, and we're quite happy that most of them are actually relying on Elasticsearch to do storing, aggregation, and visualization. And speaking of visualization, analytics seems to be the trend nowadays. A lot of people want to get insight in what's going on. And again, Elasticsearch is one tool that can help you with analytics. This is, again, from another customer of ours that has quite a big cluster, about 20 petabytes of data, which is, if you come to think of it, quite a lot of information. They get around 100 million web clicks per second, and they aggregate that and basically create their own product, which is, here is what's happening with your website, here's how your users perceive your presence. So, all is fine and dandy, nice names, nice graphs. What is Elasticsearch all about? How does it actually look like? So, we think it's quite simple, what we call plug and play. So you just get to our website, you download a tar.gzip or just a zip depending on your preference. You get it, you download it, expand it, and that's it. You can just start it. There is no extra setup. As long as you have the JVM on, as long as the JVM works in your machine or in your cluster, that's it. There are no other dependencies that we require. There are no other downloads. That's it. All right, we started the node. Let's put some data into it. Pretty simple. Elasticsearch relies on REST. So as long as your tool, or as long as you can do an HTTP call and send some JSON document, this is what Elasticsearch uses, you're good to go. So here we're using curl. I assume everybody here is familiar with curl, right? The command line for curl grogs URLs. We just do a put request. In this case, the endpoint localhost 9200 is what Elasticsearch listens for, and then the rest of the URL, right, is REST. So in this case, we're putting a product under ID1 under products. So if you look at the structure, right, like most REST or most storages, if you think in terms of storage, you end up with different namespaces. So here, the first namespace would be products. For a relational database, that would be similar to, let's say, a database, right? You connect to MySQL or to Oracle, and then you select a database. That's a big namespace. And then from there, you can select tables. If you come from tables would be product here, the database would be products. If you think in NoSQL, that would be similar. You have a series of collection, that would be products, and then a collection, which is, again, the equivalent of a table, that would be products. In Elasticsearch terminology, that's the index, and then you have the types. So here we put the type product under the index products. We also specify the ID, but that's not necessary. If you don't specify one, the data is just merged. If you want to update it, again, it's REST. I'm just doing another put request. I'm specifying the same ID. I change the data, and that's it. And if I want to read, again, just as well, I just use curl. In this case, I'm doing a get. I could do a key lookup, which is specify the ID, but that's not really interesting, right? We have data, but typically you want to explore data, which means you want to search. So in this case, we're doing a search welcome. So since the slides don't really, well, they're nice and everything, but it's typically nice when you can do a bit of a demo. This is what I've prepared here. So I'm using a crappy laptop that has Windows XP on it. So if I can do this live, it means everybody here can do it, okay? That's my point. So I have Elasticsearch here. I just started it, right? I have some data loaded into it. You'll see later on what it is, but we'll start up now with the fresh new index. So we can put some data into it. And here I have some scripts, pretty basic. So since we talked about adding data, this is a script. I have here 3 put commands when I'm just adding here under demo and question some data. That's it. I haven't done anything at all. So I haven't declared any schema. I haven't done any setup. I just started the server, and that's it. So now I'm connecting to the default port, localhost 9200. Again, I haven't deployed any WAR. I haven't set up any server. Elasticsearch is self-contained. All I did was, as you'll see, as I add more nodes, I just started up. That's it. Okay, so let's do this. I get back some responses here. Again, JSON, Elasticsearch, right? This is REST. It means HTTP and JSON. Currently, it says that for each request, return some data back. So I did 3 puts. So all of them, it says, yes, everything is OK. This is where I added the data under index type. I have some things like ID, which I specified versioning. There are also things like TTL, such as time to live. I'm not going to go too much into that. But as you would expect for any store, you have things such as time to live, so you can put in data that automatically gets exported. Or, again, because there are multiple clients talking to your store, you have things such as versioning, so you can implement optimistic locking, so you can see whether that part of information was updated or not. We also have some interesting thing here at the bottom. Shards, total, successful, fail. We'll talk about that. But you can see that even though I'm on one laptop, fairly old, running one node, I already have this notion of sharding, right, which suggests partitioning of data and things like that. So there is no switch that you have to turn on. Elasticsearch is designed to scale, whether using on one node or 1,000 nodes. That's part of the deal. There is no, opt in and out. Okay, so I've added the data, and now I can, do some basic things with it. Let's say, such as I can just do all the data. So what I'm doing here, I'm just connecting, I'm doing a get to the endpoint demo. This is my index, so I'm getting all the information on this index. I do a search. I don't specify anything which says, give me all the data. And the pretty there is just to get a pretty JSON. So rather than having one big line, I can have something indented. So it looks something like this. So if you look here, I can see, well, I get the JSON. It took 0 seconds, there was no timeout, and I have 3 hits, and you can see there within the hits what exactly happened, right? Index, type, ID, score, and the actual content for it. Now this is, well, if you're a machine, you can process this very nicely, right? JSON is JSON. So for this particular presentation, or in general for command line, we have this small script that one of my colleagues did, which is called Elasticsearch. It's just a Ruby script that uses ANSI colors, so you get pretty colors within the console. So I can do something like that. Again, this is optional. I'm just using it for the demo purposes, so we can very easily browse through the JSON. So you have something like this, which means I can still see here the JSON, right? Right here, you can see it's a bit grayed out, but just because it helps us, right? This is what the tool does. You can see the examples very easily printed out. So you can see I have 3 hits. This is sort of the title. This is what it matches, and then you can see some content over it. So I'm going to use, you'll see that I'm going to use curl and this Elasticsearch, so it's very easy for us within the command line to see exactly what the JSON do. So, okay, pretty basic. Let's see something more interesting, such as let's do a bit of a query over, not just raw data, but look for a particular item. In this case, let's look for all the documents that have Elasticsearch in it. Again, another curl request. In this case, I'm using Elasticsearch. So I can see, again, the JSON, as you can see, I only get 2 results. But you can also do interesting things, such as do more complicated queries, like this one. So I'm hitting demo, and then I'm looking for all the documents or all the data that I break down into fields. So I can have title with Elasticsearch. You'll see here that I do a bit of boosting. So interesting more in the documents that have Elasticsearch more than the author being John, and also have a certain date, right? So pretty basic stuff. You can very easily start querying data, right, out of the box. I haven't done anything. So far, so good, right? So easy to get started with it. Now, again, I just started. I put in some data. I started querying. Okay, what about the scaling part? Well, as I've mentioned, Elasticsearch by design, always when it deals with data, it assumes or it is designed to scale out. Scale out means rather than buying a bigger box, more powerful box, which you can do, that's fine, you add more machines to it, right? And the reason for that is fairly basic. It's a lot cheaper to add more machines, to buy new machines, rather than after a certain threshold to buy a bigger machine. So there are other interesting things that happen behind the scenes, such as whenever you add a new machine, a new node, what we call within Elasticsearch, a node being just another instance of Elasticsearch, so I can run, as you'll see in my demo, multiple instances on the same machine. It doesn't have to be hardware-based. It's entirely up to you. The data automatically migrates. So what we're doing here is, well, we take your data, right? We put it on the available hardware, which is one node. You add a new machine, in this case, a new node. We're going to balance the data out. And there are 2 reasons for that. First, if you have multiple nodes, then the load for that particular type of data is going to be split in parallel against the 2 nodes. So, right, the more machines you have, the more resources you put at use for querying the data. But also, we're going to split the data between that, not just in terms of computational purposes, but also in order to balance it out. So in case one node dies, we can actually resurrect the data from the other nodes. So I was looking here in terms of sort of terminology, and if you've used any type of a distributed system, or you've started doing partitioning of data where it doesn't fit on one machine, you're pretty familiar with this. We have what we call shards. So whenever you add in data, we take that piece of data and we split it up into buckets or pieces, and we call these shards. And this, again, happens automatically. For example, if you don't specify anything, the default out of the box is to split any index or any type in 5 shards. So data always gets split into these buckets. And then your entries enter one of these buckets. Now, initially, everything sits on one machine. You add a new node or another machine, then some of the shards are going to be evenly split between the 2 nodes. And again, there are 2 reasons here. One, performance. So now the queries are balanced between the 2 nodes. The other one is, in case one node dies, I still have the other machine with some part of the data that I'm looking at. Now, sharding typically is used, again, to make use of the additional hardware. But when you're looking at resilience, this is where we have what we call replication, which is, okay, how many copies of the data you want? Because again, if you lose one node and you don't have any copies, basically you lost a shard or multiple shards, which means one portion of your data. So ideally, you would like to have copies. Why? Well, because if one node dies, I still have a copy somewhere in the cluster, and then that copy can be put to good use. And it's exactly what we have here, the shards, and then within the copies, we have what we call primaries, which means I have the data, and this data is the final authority, the masters, for example. All the writes first go to the primary, and then I have copies, or what you can call slaves. These are the replicas. Why does that happen? Well, because if a node dies, and you only have replicas, or potentially a primary, you have to know which one, in case of a conflict, which one wins. And the primary always wins. So basically, the authority in terms of data use. So in this case, let's see how that works. Currently, I have only one node, is this guy here, which I just started. So again, because everything is REST, we can do a bit of a querying and figure out how our cluster looks like. So let's do a bit of a querying. First, let's see what this guy looks like. We have an endpoint, cluster state. Right? I'm putting pretty just so the JSON is not one line again, but actually it's a bit more readable. I'm going to use Elasticsearch as well. And this is what it looks like. I get quite a bit of JSON here. See, this is why Elasticsearch is good, because I have a lot of information about the cluster. I have things such as metadata, what type of templates. So I added in data, Elasticsearch automatically did an introspection, figure out what type of JSON, created some sort of a presentation internally, and you get information about that. About the various indexes, including the one that I'm going to show you later on. And I also have information about the routing table, how things are looking by default. You can see information about the shards. Again, the splitting up of data between the various indices, where they are based, things like that. And if you'd have to represent this visually, it looks something like this, right? So I have one node, one instance of Elasticsearch. In order to have this Kibana and Stack, these are indexes. I'm going to talk about them in a minute. And then we have this one, demo. Right? I just added some data, it's small data, but again, this is split in 5 pieces or 5 shards, and you can see him here, 0, 1, 2, 3, 4, and this P that stands for primary, right? So I added in the node, out of the box, I'm splitting the data into 5 pieces, and I have one replica, one copy. That's the minimum amount. So everything sits here. Now, interesting enough, I have this thing called unassigned. So for all the data that I have, or all the shards, I have a replica of 1, which means I need copy on a new node, but I don't have a new node anymore, right? I have only this node. So all the data sits here. All the data is made primary because it's the only one that exists. But we also have replicas, one copy for each of the primaries, but I don't have any other node to put it in. We also have one REST endpoint for this. Again, there are some tools for this, but for this particular usage, I'm just going to use the command line, which is cluster, but not a status, but health. So if I use that, I get this basic information which says, well, the cluster name is Elasticsearch out of the box, and it has status yellow, which means I haven't lost any data whatsoever, but based on your setting, which indicated out of the box that I need one copy of the data, I cannot do a copy of the data. I haven't lost any data, so I'm not in the red, but I don't have an additional node to put all the copies in, right? So currently, all my eggs are in one basket, so that's no good. So what we can do here is, let's see what happens if we start another node. So Elasticsearch, I'm going to name the node just so we can actually see what's going on. Out of the box, you don't specify the node. Elasticsearch is going to pick a random, what is that? Not Maven, Marvel character. See, I've been spending too much time with Maven, now I confuse the two. And there are quite a big number of characters, but for having node 1 and node 2, at least in my mind, makes things easier. So we just started the node, and if you go to the command line, if you look at cluster health, you see, okay, now I'm status green. And why is that? Well, because now I have 2 nodes. So now I can actually, Elasticsearch can get all the replicas that were previously, unassigned because there had no other node to put it onto this new node that I just added, right? So again, I haven't done anything except I just started the node. And this is what we mean by cloud-friendly, right? There is no discovery. I haven't done anything. So out of the box, it can automatically communicate with itself. And in fact, if you look at the protocol, it's actually designed in a way that if you have a restricted environment, which is what typically cloud environments are, such as have firewalls, things like that, is actually quite light on the network I/O. In fact, it's also pluggable. So if you have your own protocol or own discovery mechanism and the default configuration is not enough, you can actually replace it entirely. So now let's see what happens if we add yet another node.
Question.
Yes?
If you're out on like Amazon
Well, yes, I mean, we have even what we call a plugin, which means we have a, you could configure this yourself, but we have something that is configured automatically. In terms of Amazon, this is what actually Spring AO, for example, uses. It's entirely up to you. It's highly configurable, and you can even set up different rules. So if you have it between different zones or different WANs, if you want, you can have two clusters that actually communicate with each other, or can they both be part of the same cluster? So it's pretty configurable. And this is something that we're going to improve in our next version, in that we give you even a better dedicated API. So you can do this right now, but now we give you a dedicated API, so the workflow, it's a lot easier, and we do a lot of things that currently you have to do yourself to some degree. So, right, I started the third node. If you look at the cluster state, you can see that, again, the node joined, because, again, out of the box, it's just going to join the Elasticsearch cluster. This is something that you can configure. But things are a bit interesting. You can see that now I have the data. Previously was just sitting right here. The primary is on one node and all the replicas on the other node. But now, because I have additional hardware, you can see that the data sort of migrated. So now I don't have all the shards on node 1, but actually some of them have moved to node 3. And you can see I have a mix and match between primaries and replicas. And it's exactly what you expect in a distributed system. Right? You want to have some copies there, some primaries there, here and there. Basically, you want to load balance the data and your copies between your clusters, so you don't have everything in one basket, right? So when disaster happens, you actually are covered. So now I can very easily, right, if you have a big data set, or if I wouldn't be talking, if you look at the script, you can see here that the relocation shards or initialization shards or unassigned shards actually happen because this is all live. So for example, right here, if I just kill this is node 3, right? I just killed it. If you look now at the cluster health, you can see that I have initializing shards and the status is yellow, because what happens is a node died. So until it figures out what to do, it knows that it hasn't lost any data. It's yellow, but because now I have to go from one state to the other state, until that happens, right, there is this migration. And that's why I have here initializing shards, which means I have copies on some nodes, but now some of them has to be promoted to primaries because I have there some primaries, right? Now the copies, I have to replicate them. Now I don't have only one primary, I don't have the replica, so I have to update on another node, right? There is this load balancing that now happens dynamically. And if I look at the cluster state, you can see that now I only have one node, and again I have this mixture of primaries, replicas. And in fact, I can even kill this node. See, I'm really pushing for it. And now it's still yellow. I haven't lost any data, but I'm back into the initial state, which is I don't have unassigned states. So if you look here, you can see that, right, all the data now sits on one node. Everything here was made a primary because I have only one node, so all the data that I have is ultimate source of truth. And now I have unassigned shards. These are copies, right, of the primaries, but I don't have any other node to put it. Right? And again, I haven't done anything except start Elasticsearch, which I just unpacked. I haven't done anything else, right? No configuration whatsoever. So really nice. Again, this idea of elasticity and for things to happen automatically, so you don't have to think about it. Now, there are a lot of discussions that can be, yes?
You have 3 nodes.
Yes.
You have a prime shard is on 1 and 2.
Right.
1 and 2 go down at the same time.
Okay. So this is why I have this GIFs of the text, which is very convoluted, but hey, it makes sense. So, right, we start with node 1, right, which is here on the left, right? And now currently we have all the data here. We call it in this case because this is where the example is products, which means I've split it into 5 pieces. I have here the pieces, right? This is the primary, the green stuff, and then I have the data here, the copies which are unassigned. I don't have any other node to put it, right? I add a new node. Then what happened was the copies went to one node, and then the replicas went to one node, and the primary remained in the first node, right? So in this case, we have yellow, because it means we have no data loss, but still we cannot move all the copies to where you specified. And at this point, we got into green, which means you told us to make one copy, and we have those copies assigned to a node, and we also have the primaries, right? So if you add a third node, you get from this state here to this state here, where you start to load balance and use the data available. Right? So we have a primary and a replica on node 3, let's say the replicas on node 2 and some of the primaries on node 1, right? But they are balanced. So now our question is, what happens if node 3 and node 2 at the same time go down? So this is where you get into independence. You said one copy, right, which was distributed evenly between 3 nodes. So in this case, right, I lose all nodes 2, so I lose all the copies here. I lose 2 primaries, and I lose 1 copy here. So I end up with node 1. When node 1 has 1, 2, 3, but you lost 0 and 4. So the first and the 5th shard were lost, right? And at this point, the cluster is in the red because it said, okay, disaster happened. I lost data. I still have some data, but I lost some data. So what can you do in this case? Well, if you think about it, 2/3 of your cluster just died. And you said, I want 50-50% of data reliability. So I want 1 copy. If you want to avoid this use case, you would have figured for 2 copies, which says, I want 1, I guess you could call it 30-30 availability, which means I want a copy on each node. And in that case, if you had 2 nodes dying on you, you would still have everything on 1 node. Now, the interesting thing here is there are no, within a cluster, not all data is the same. You actually have some pieces of data which are quite important, right? And for those, as you specified, if something wrong happens, I want to have multiple copies because this data is very important for me. You might have data which is not that important. For example, it's from 2 years ago. I don't really need any copies for that because I only have it in some archival system. So this is just some stuff that I have. But if some hardware failure occurs, I can just load the data in. That's fine. And that's typically the case because we don't have infinite hardware. Now, the nice thing about Elasticsearch is all these settings are not global. So they are per index. So you can specify that one index has multiple copies because that's important. And one index, for example, has no copy and has multiple shards. So I divide it into multiple pieces, right? And this thing happens dynamically. You don't have to restart the cluster or anything, right? That's why having indexes and types is important because you can slice, you can sort of, not partition, but you can think of your data in different ways, right? If you put everything under one index, it's as you have one big book. But typically, right, you split it up into different books. And then you can have different indexes with different settings, which are not just about replication and cluster setting, but also in terms of what the data representation is, how Elasticsearch can use it. For example, and I'm not going to mention it because we might be running out of time, is within your cluster, you can very easily specify routing rules. So this is quite common that as your data ingestion grows, you end up with a cluster that has a lot of data. New data, which is quite interesting, that is accessed a lot, and old data, that is not that interesting anymore. And actually, you can specify simple rules. By simple rules, I mean you just tag with whatever name you want, some machines within your cluster as being old, and this is typically where you have old hardware, old computers for, let's say, 3 years ago, and you can move the old data there. So all the data goes there on the slow machines, and then all the new data, or the rest of the data stands on the rest of the machine or on the new machines. So you can even do things like, position or have your data stick to certain nodes or to certain machines. So it's entirely up to you how you decide. And again, Elasticsearch deals with multi-tenancy. So if you want to go one step higher, within the same cluster of physical machines, you can have multiple clusters of Elasticsearch on the same machine there. That's not a problem. So quite flexible, again, light and versatile in what you want to do. Now, one thing before, because it's good to understand how this, partitioning and scalability works. But most people think that, oh, now I have to actually, tweak with it. No. I just did this stuff because I wanted to, I guess, play around with the demo gods, but in fact, to show you, that things are there, that things scale out. But for the most part, there is no need to actually change any settings because the defaults work for 90% of the use cases. So unless you have, a big amount of data, and by big I mean something really big, think about 10 or hundreds of terabytes rather, or petabytes. If you actually done your, benchmarking, and again, there is a problem with your hardware, then typically this is where you start to tweak the replication, potentially the sharding, but for the most part, don't think about it. Just start using it, and then once you get very confident with it, start playing around with it. And again, you can do this dynamically, you can do this programmatically through different endpoints, where you have, the default configuration that you can use. We have this file, plenty of options in there. Speaking about clients, so far I've used, and I'm going to use REST because it's simple, yes?
So when you said default configuration, can we take that same configuration to production?
Can we take the same configuration? Yes, I mean, it's entirely up to you. There are no restriction whatsoever. Just to make a point, this is Elasticsearch, right? This is one file, it's one folder that I just downloaded here. This is where the data is. So you can actually migrate that if you want. Here is the bin folder configuration. This is a file, right? Here it is in all its glory. These are the libraries. This is where you have some logging. Again, you can configure it, and that's it. I'm using Windows XP. If this stuff works here, I'm pretty sure it will work anywhere. So again, there are no settings, registry, or anything of that. Everything is self-contained. Everything is nested. So in terms of clients, out of the box, you have two things. You have HTTP, the REST, which is what most people use, and you also have what we call the transport client. This is the native Java protocol, which Elasticsearch uses between its node to communicate with data. So it's up to you to decide, especially if you're in Java, right? Folks that are not using Java probably are not going to use a native Java protocol. They're just going to use REST, which actually is what we recommend. Why? Because it's internationally known, works across platform, across clients, is easy to debug, and it's quite friendly. We also have an endpoint for Thrift, if you're into that type of thing, and also mkHD. This is a list of platforms, not clients. Platform or languages where you have clients for Elasticsearch. Typically, for every language, we end up with 2, 3, 4, in some cases 5 clients, so it's entirely up to you. What those clients give you is the ability to already have some APIs that you can use. So natively within your code, you can use that. Underneath, the client still does REST calls to Elasticsearch, and that's quite nice because it means you can actually take a look at the representation and start using it. The ones there with the question mark with the asterisks are actually the ones that are to some degree officially supported because the authors and maintainers are actually working from Elasticsearch, so it's part of our territory, and we're actually going to expand within other languages as well. Talking about Spring, there is a session tomorrow, a lightning talk about Spring data support, and Elasticsearch is going to be featured there, so I'm not going to spend too much time on that. But just know that there is a Spring Data Elasticsearch project. It's official, so it's part of the Spring Data family. It was back then it was called Spring Source, now it's called Spring Projects. And it gives you, if you're familiar with Spring Data, you should feel right at home here. So you have the usual goodies. So whenever you want to use Elasticsearch within a Spring application, this is probably what you're looking for. So you have easy configuration, so you can very easily configure your application to connect to Elasticsearch, whether you want to use XML or Java config. Those are both available. You have the dedicated templates. So you can do wine-liners, such as creating mapping if you're not. If you want to tweak the default configuration, you can create indices. You can do things like bulk operations, scrolling, streaming, and also, most importantly, you have a lot of query options. This is where the richness of the search engine comes into play, right? And you have a lot of options so you can actually find your information effectively and fast. And we also have support for repositories. I assume some of you here are familiar with the repositories, right? This is one of the nice things in Spring Data. Well, you have Spring Data repository support for Elasticsearch. This is literally designed by contract. So you give us an interface, you tell us how that contract looks like. So in this case, where you have finders, and we're going to implement the actual code for Elasticsearch. Now, the nice thing about repositories is you can very easily move between different implementations. You can have one for JPA, and then you can just move that contract to a different store like Elasticsearch here. The repositories are not an abstraction against all stores. That's not what repositories are. So you still get access to the nice goodies underneath of the story. So you can have things like dedicated queries, as we have right there at the bottom. This is something which is specific to Elasticsearch. And we have, talking about queries, a lot of sophisticated query creation. So you can get the method name and have advanced queries created out of it. But anyway, tons of nice things there. Speaking about HTTP and REST, right? REST means you are dealing with JSON. And JSON is quite nice. It's fairly simple and yet very rich in what type of things you can do with it. And in fact, Elasticsearch not just talks using JSON, so all the queries are to some degree made, or all the requests are done through JSON and it returns JSON responses, but also internally it uses JSON. So that's literally its structure, if you want. Right? You can have things like IDs, right? Numbers, dates, geolocation lists, and also maps. And it's interesting that we get questions, well, if using JSON, is that effective? Because JSON isn't exactly concise, and you have a lot of white space, so what happens there? And from experience, it's very unlikely that typically the JSON network I/O is the biggest problem that you have. If you have that problem, then good for you. That's a good problem to have if everything else works fine. But Elasticsearch gives you the option of supporting both JSON, so native JSON, which you can just send, or automatically support SMILE. This is binary JSON. It's a bit different than a BASIN, or binary JSON is known. BASIN, because BASIN is not really streamable in the term that you cannot just select certain fields. It's just one big block. While SMILE, which is another binary JSON protocol, which again, Elasticsearch understands out of the fly, you can actually select. So if the data comes in, you can just stream up the data that you want. So it's quite effective. Also, in terms of storage, Elasticsearch automatically does a lot of nice compression. So as you move between different revisions, you can just reindex the data and end up with compression. For example, when you specify a number, even if it's long, right, we can look at the value and figure out that if it's small enough, we can actually do bit compression. So you can only use 1 bit rather than 8 bits for data. And especially when you have a lot of documents, that applies automatically. And if you look through the lists, you'll see that we do a lot of interesting things to make sure that we pack up the data, including things like archiving, figuring out that you have the same data being repeated, and doing the compressing. So for the most part, don't worry too much about it. You have plenty of options. But again, the engine out of the box does a lot of work in this regard. Talking about searching and what you can do around finding data. Now, Elasticsearch for search uses underneath Lucene, which means you're using the best open source search engine within Elasticsearch. If you're familiar with Lucene, this probably feels quite natural. If you're familiar with Google, then again, it should be right at home. So you can do a lot of things here. I can specify to look for terms. It's already done, right? I can look for Apple and iPhone. I can look for phrases, right? Words in a certain order. I can look for proximity, so I can look for words that appear within a certain distance of themselves. I can use fuzzy search, which is actually what most people want. Whenever you have a typo, whenever you're looking for something that resembles that thing, you can use fuzzy search, which basically calculates the Levithian distance between the different letters within a word, and depending on the gradient there, which is between 0 and 1, it can look for the identical word or something which is completely different. Wildcards, right? Pretty obvious what they do. You can do boosting, which is, again, another powerful feature. Boosting means I'm looking for data, but I'm looking for documents where I have Safari and Apple, but actually the ones that have Apple in it are of more interest to me, right? So I'm now starting to add a bit of weight. And there are, again, a lot of options that you can do here in terms of scoring, because if I just have Apple and Safari, then I'm going to have a lot of documents. But if I can just stay focused on the one that have more Apple than Safari, then I'm going to add a bit of bias. Ranges, we support that as well. Obviously, data ranges, also lists, so that's up to you, that's a user defined. We also have here, and it's not, unfortunately, on this slide, support for geolocation, so you can specify literally ranges of distances, and there are various ways in which you can specify that depending on the format. Booleans, which is what you expect, you can say I want this but not that, or this and not that, and also support for fields. And what's interesting is that if you look right from the top, you say, okay, full text search, I don't have any expectation of the data, I'm just looking at the content, right? But as you see, as you go towards the bottom, you're now looking from something which is really unstructured search to some sort of structure, meaning that these are not just text. Some of them is numbers, some of them are dates. Oh wait, I can do actually some logistics, or sorry, some logic between them, or I can even break it down into fields, right, as I do here. So I'm looking not for anything, but for stuff that has a title, a field title that has iPhone in it, or it has a body that has iPhone in it, right? So now suddenly I'm looking at the data and I have some expectations, but I don't have to do that beforehand, right? This happens at, again, query time. So you have a lot of flexibility and you can mix and match unstructured and structured data. There are, again, no requirements from the get-go. Now, I've already, seen, and you've seen in my examples, querying when you have a lot of, stuff here. But what's interesting is once you start using this more, you end up with it becomes unwieldy. You have this big URI. So typically, what most people use, because it's more powerful and human readable, is a query DSL, which, as the name implies, is a DSL for querying, and is basic JSON. So you can do a curl request, right? And rather than specify here a big URI, you can just specify within a body the JSON itself, which is I want to do a query which is filtered. So the way it works is when you do a query, you can do what we can think of them as sub-select. So you literally say filter the data very easily, locally, and then run the query. So what happens is in all the nodes, first of all, the data is very easily sliced, and then you do the query. So here I'm doing a query, which is filter. You'll see the filter in a minute. So I do a Boolean, which means I want to look at all the documents or all the data that has an author in it. The author has, again, this is what we call in JSON, what is called in JSON a object. So it has a field first name that has Clara in it. Even something that remotely resembles Clara, that's fine, right? I have the fuzziness of 0, 1, but also I'm looking for documents that have Elasticsearch both within the body, but also within the title. The title is going to be boosted up, so the documents are going to be returned first. And coming back to the filter, I want the data to be filtered out, to be split. Again, think of this as sub-selects, or if you use Hibernate, this is a similar concept in terms of filtering. I want the data to be broken down. So I want the documents that are featured, that are published from 2013, and have certain tags in it, such as search. So, explaining about that is sort of dry. So what I did was get Stack Exchange, or Stack Overflow was quite big to fit into my machine. That was big data, man. So I got the programmer site, which is about, 200 megs, the whole zip, this Stack Exchange, the whole website. They dump or publish the data as XMLs every 2 months, something like that. So I took that, I've downloaded that, and imported into Elasticsearch. And this is what the stack index does. And the script for that, you can find them on GitHub. They are just because my colleagues like to mess with me because I'm, I guess, a Java guy. First, we have the guy that did the Clara, that did the Ruby client, which did the conversion between XML to JSON. And then we have another guy, Honza, that used Python to do the actual import and break down the file and do the import. Why? Just because they wanted to mess with me. Anyway, so we have here the stack. So let's do some queries against that data. Right, so this is the actual Stack Exchange. Now, Stack Overflow and the subsequent sites already use Elasticsearch, but what it would take if you'd have that data on your machine and you want to do something similar. So here I have a couple of searches. So let's look for all the data within programmers Stack Exchange, where that mentions Spring Framework within the body and the title. Right, so in this case, I'm using the query DSL. So rather than having DRI, you can say I'm doing a query, which is multi-match, which says do multiple matches for this query on this field's title and body. So I can use, again, Elastic Cat, and I get some data back. Let's see how that looks like. 10 results. Let's move, sorry. So if you look here, this is the raw JSON, right, which is grayed out. Unfortunately, I do a lot of scrolling because this is a smaller resolution, so that's it, right? But the raw JSON, if you look at it with Elastic Cat, looks something like this, right? This would be human readable. So I have the first question, why not Spring Framework, score, index type, and then the actual body, right? Notice that it's already HTML. View counts, rating, right? All the data that is available. Again, for this type of thing, I haven't done anything except translate into JSON and then just send the raw JSON. I haven't done any mapping. The mapping the breaking down of JSON into an actual document happened already on the fly. The second question, why does Spring Framework do? Should I use it, right? And so on and so forth. And you get there, right, 10 results out of 5,715. Pretty basic stuff. You can do things like filtering. So I want to run the same query, but only on questions or posts that have been created this year, 2013. So I do that, and now notice, right, that I have only 771 questions. And, right, if I look at the first question, you'll see that it's a bit different. Server FTP with Spring transactions, confusion over configuration, right? Okay, so far so good. Let's restrict that to only posts that have been in US. So far I just did a full text search of Spring Framework. I did a filtering on in this case, a range on the creation date. So now I can look also at where the owner actually posted in. Now the data, or you're not, let me put it this way, when you log in, you're not mandatory for you to specify the location. So that doesn't mean that the posts that are not filtered here don't have a location, but rather if you look at the data, you'll see most of the posts don't actually have a proper value for owner location. So we're going to get a bit more data than you would expect. Right, most posts are probably from US. But the ones that have declared their location and have actually asked the question in 2013 are about 70. Right? And again, you can see, you can browse the data and look, for example, let's see, owner, favorite ID type. I'm just trying to see whether the location appears somewhere. And I don't think it does. You have here the tags, comments, but no location. We'll see that. We'll come back to it in just a second. Cost of switching to Java. Interesting. You can do things such as filtering the amount of data that is being returned to you. So when you do a query, right, so far we have quite a lot of JSON, so literally all the data that was available was sent to us. So what we can do is take the same query, right, where we do the matching based on the location, we do the search, do a filtering, but you also say, well, return me only these fields. So basically take the data, strip it out, because this is the information that's available to me. And why this is useful? Well, because it reduces I/O within a network. This is the biggest problem that any system, distributed system tends to have. It's not CPU, it's not memory, it's network I/O, because there is a lot of data that has to flow between different applications. And in this case, if you're just going to do a search, right, and then show some results to the users, there's no point in loading all the data just to dump it, right? You typically want some totals or just some headliners. And it's exactly what we do here. So now you can see that I don't have what we call the body, or this is what not Elasticsearch, but Stack Overflow uses as body. That is the body of the post. But I've just stripped that down to the score, index type. These are already implied with the search, but things like creation date, and in this case, owner location, right? So at this point I said, don't give me all the data, but only give me this field, right? So Elasticsearch can just display, the query and also the information that is available to it. Yes? How should the store? Okay, so that's a long question. I'm just going to try to give a short answer to it. Scoring depends, tells you the relevance of a document. And the relevance of the document depends on the analyzer that you do. That is, I have a couple of slides later on. That is, as data comes in, is being broken down into various pieces. So you might say, well, get out all the words that I'm not interested in, such as, this is what is called stemming, so ing, merging, walking, right, remove that. Do things like and, or, not, those are removed. And then you have a lot of text. So if you have a lot of words potentially that are being repeated, then you have a certain score for that document. So when you do a query, depending on the terms that are being used and the terms that are present within the document, you end up with documents that are higher on the request. And again, this is something that you can customize. This is sort of the simple line. Within our documentation and within Lucene, you have a lot of explanation what scoring is. But basically, scoring is something that the engine internally uses in order to figure out how relevant for a certain query a document is. And again, this is something that you can customize because depending on what type of data you have there, some document might be more important than the other. And this also feeds up into that scoring, right? When you have this tilde 10 or upper arrow 10, that fits into the scoring. Speaking about scoring, I can say, you know what? I want all the posts from US that specify, in this case, I'm using Java because we didn't get enough information with Spring from users located in the States from 2011. Give me all these fields, but I want to do some, right? I'm looking for the documents that have the most posts, the best score, right? So I don't want all the data, but sort them based on the relevancy. So what I'm doing here is quite interesting. I'm running a script. So literally, when I do the query, I can ask Elasticsearch to perform custom code. You can use any JVM scripting. You can even use Java. But typically, scripting is quite nice because you can just embed it within your query, which is exactly what I do here. So I'm saying, give me all the documents from owners within states that specify Java within the body, but especially in the title, from 2011. Return to me only the title, owner location, owner display, blah, blah, but also run this script, which says make sure that you get this field document rating, right, and multiply that with a score. So what this means is that I'm looking at the relevancy of the document within my query, but I'm also multiplying that based on the value that the users gave. So what I'm doing here, I'm saying, find me all the data, right? Look at the data that is important, that matches this query, but also take into account what the users, in this case, a value within the document said. So this allows me to add some weight to the query, which basically makes some documents to appear first, right? Now, if you think about it, this is quite powerful because it allows you to customize the search. You don't just, plow through tons of data, but you can actually very easily select it. This is literally like selecting, give me the best rated post on Java since 2011 on this particular topic, which is Java. What are the similarities Perl and Java? Rating, 12, nice. This one, 11. 6, 8, system down. I was expecting system up and down, but I guess I didn't get lucky. So, quite a nice, some interesting things there.
Where is the script applied?
So the script applies to the document. That is, so if you look here at the declaration, sorry, not this one. This is a bit for later. So this means Elasticsearch is going to do the query. It's going to go to each node where the data reside, where you have the shards. First of all, it's going to apply the sharding. Then it's going to apply the query. And then when it returns a result, it's going to execute the script. So this is on the return side. So this is where the data still sits. There are no returns being done to the node. Again, everything happens in parallel. That's the beauty of a distributed system. When you do a query, things are not serialized, but everything happens locally and then is being returned or reduced, if you're thinking of Hadoop terminology, to the user.
What's the size of this data on the file system?
Let's see. 410 megs. That's probably, I don't think I have the dump of the data yet here. There it is. So the raw data, this is JSON, the JSON conversion is around 300 megabytes. The rest are basically the additions that come from indexing. And this is the slowest index that you can use, which basically says get all the data, duplicate all the data, and then do the counters. Plus, don't forget that index, because I looked at all the data within within Elasticsearch, holds not just Stack Overflow, but also not demo, because demo I just added, but also Kibana, and you'll see that in a moment what it does. Right? This is just another index, so that's not representative for all the data side for Stack Overflow or whatever Stack Exchange, but also all the other data that's within that particular node. So speaking about search engine, another interesting thing that you can do, and this is where it starts shining and gets us to the analytics, is doing highlighting. And highlighting is quite interesting because it means multiple times you're looking for data, but as the data comes in, you're looking, okay, why is this data relevant? Where does, where do the item that I'm looking for appear? This is a web page, This is where it sells Hawaii. Where exactly in the page? If the page is too big, I have to actually start doing an additional search within that particular page to know where Hawaii actually appears. And this is something that Elasticsearch is called highlighting, which says, okay, find me all the documents and then highlight, tell me within that document where does my search apply. So we have the same query, right? Owner location, title, multi-match, range, script, fields, and this is where we specify the highlighting, which says, look for this query, Spring and Java, but do the highlighting based on the title and the body. So do all the query, but in particular, I'm interested in where this appears within the title and the body, and give me a fragment, right? Give me a snippet that matches that, and make that up to 50 characters. So for example, I can run this, and you can see, the title, everything else, and the highlight. In this particular case, Java appears only the title, and this is up to 50 characters. If I move a bit higher, you can see on this post I have Java, 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 right in the body and the title. Right, Java, 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 Java. A lot of Java. Perl and Java style themes, right? Notice how for every match, I get a nice highlight in there, right? I haven't done anything here except do searches. I haven't done anything to the data. I haven't prepared the data. I haven't said, look at Java, look at Spring, add in a bit of highlighting there so I can look at it. No, that's the beauty of having a search engine. That's the beauty of having a Lucene of analytics, that all this exploration happens in real time. There are no, there is no stepping back, there is no setup. You just dump the data and then start exploring it. And this is quite powerful because it means the feedback loop, because this happens in real time, is quite short, which means I can run a question and then another question and then another question. I don't have to wait for it as I would have to with a batch system. Right, so, okay. Quite interesting. Quite interesting in terms of querying what you can do when you have a real-time system at your disposal. And again, if you take a step back, again, we've done full text search, which means I don't know anything about the data, just find me some matches. And then we slowly migrated to what was structured search, which is, you know what, actually I have somebody in a title, actually I have a date in there, actually I have a location, right? So now I'm looking at the data with some sort of mapping, with some sort of structure. But this is not something that Elasticsearch requested. This is something that your data has and Elasticsearch can automatically understand. And then you get to this thing, right? Custom scoring, such as give me all the posts that have the highest rating in there. And actually, in most cases, this is what you want, all of them, right? If you think of, forget Stack Overflow, but find me all the Chinese restaurant named Chopsticks within 10 miles of me, right? You do a lot of things. First of all, you look for a full text search, Chopsticks. I'm looking for everything that has chopsticks in it. But now it has to be a restaurant, okay? So I have some sort of structure. I'm looking not at the menu, but at the title, right? I already have another structure. And now I have some more context to it within 10 miles. So now I have to know where I am. I have to do a bit of geolocation. And then you can also do things like custom scoring, such as give me the ones that have the highest rating. At that point, I'm not interested in all the documents, but I'm adding a bit of weight. So I'm saying some are more relevant than the others, right? And with the query DSL, that's quite easy to actually construct that, right? It's just like I'm writing the criteria, playing around with it, looking at the results, and then figuring out whether it matches. Quite powerful. So from the search perspective, right, you have the user and the backend, the search engine. And the user is pretty simple, right? I run the query, bam, I get the results. But if you look at the backend, there are quite a number of things that need to be taken into account. Out of the box, with Elasticsearch, you have a nice experience. But if you really want to make value out of it, you need a bit of understanding of how things are. For example, you mentioned scoring, right? This is where scoring is being deducted. So when the data comes in, is being, first of all, sort of sanitized, is being broken down into fields. Then you have an analyzer. For example, is the data that I'm looking text? If so, is it English? Is it Hebrew? Or is it Spanish? That's actually relevant for the data, because if I don't have the proper analyzer for it, I'm just going to, blindly look at it and not interpret something like gibberish when actually it's an actual text. And then you have storage. It's being actually stored in order to be analyzed. Now the interesting thing here is, this happens automatically, but this also gives you insight into what's going on. So you cannot just use it just for search, but now you have information about the data that you can later on use. This is what analytics are to some degree all about. I have a lot of data. I can do queries, so I can literally sort of shoot for certain things, but can you give me an overview so I can decide what type of data is relevant to me? Stack Overflow, you have tags. This is right for LinkedIn as well, if you use that. You do a query, find me all, I don't know, in this case, people that are within my network. You get a list. And then on the side, you have this column where you can select, such as sort them by location or group them by the relationship or industry. Right? This is what, to some degree, analytics, this is what slicing and dicing is. It means I have the data, raw data, but actually I can pack with a different dimension. And now, because I have a sort of a bit of a cube, I can just very easily filter through it. A lot of people think of OLAP as being legacy, but it appears that now we have sort of rediscovered what we've done so many times, right? Grouping data, doing dimensions, aggregation, so we can very easily migrate to it. And this is where actually slice and dice comes from. That you have one big cube based on the dimension that you're interested in, such as products, as we have here. I'm interested in the products, but store them also by location or group them by location and also by timeline. So now, when I'm actually talking about slicing and dice, I'm saying, find me all the products within that location and give me, the ones from this year or last year. Very easy things. Drill down, roll up. So how does it apply with Elasticsearch? Well, because we already know about your data, right? You already added it. We can do queries, we can do highlights, but we can also do what we call faceting or aggregation. This is a way of saying, okay, I'm running a query, but can you give me an overview of the data? Well, what type of overview do you want? Well, it depends on how your data looks like. So for example, here we have posts from Stack Overflow. Right, so I have the body, I have the title, but I can do faceting or aggregation based on some part of the content. So for example, I want to say, you know what, why don't you run the search Spring in Java, but also break it down by tags. Right? This is something user defines. Every post has, based on the user, several tags. Java, MVC, web application, you name it. Right? That's something that already exists. So I'm telling Elasticsearch, when you give me the data, also slice it, group it by tags. Also, you know what? Give a histogram. This is literally a timeline if you want. Histogram which says, group them also based on the creation date by month. So also give me a breakdown. Right, slicing and dicing. All of the data, so I'm now starting to slice the data. First of all, slice it by tags. Then dice it also by frequency. When do they appear? 1 month. I want to know per month how many posts there are for Java and Spring, right? The query right here. And I also do, I want to get crazy and do statistics. So do some statistics and tell me within those answers that I get, the questions, the posts, how many have answers? What's the mean value? What's the standard deviation? What's the deviation for it, right? Because I already have this information available to me. Maybe I can actually do some bit of querying, some bit of analytics in real time. So this is where the command line is going to blow your mind. Woohoo! So see, Elasticat, you want that? Let's see what we have here. So you've already seen that, right? These are the questions that are being returned. But now I have a representation about facets. So you can see here that let's see first how the JSON looks like. So facets, right? I have the tags, total, here's some information. Then you have, first of all, the terms. This is the first facet I define, or aggregation. So literally what happens here is all the results are being returned and then also aggregated. So in this case, I'm looking at the term. So now all the answers are going to be looked at, see how many terms there are. Again, this is user-defined data. And then for each entry, they're going to be grouped, or if you like to think of it, they're going to be split per terms, which are user-defined. So I can see that in Java, I have 721, in programming languages, 102 in design, 84, so on and so forth. And, hold on. If I'm looking at the frequency, I have something similar, right? This is a date histogram. Histograms are basically, if you like to think of it, imply a timeline. So in this case, I specify the creation date. This is the field. Elasticsearch is going to automatically know this is a date, and it's going to do the breakdown by month. And it's exactly what happens here. You can see the time in this case, it's represented as in Unix time as long since the epoch. And you can see the breakdown by month. And you can already tell it's a month because the last, whatever they are, 4 digits are actually 0. Right? This is the first day of the month. And you can see also the statistics here. We have a count 1,384 answers out of 4,162. Some of them didn't have any answers. Some of them had 27 answers. The mean is 3. Some are square variance and standard deviation as well. So if you look at the graphic representation, it looks something like that, right? These are just some numbers translated into ANSI blocks, right? Because they're so awesome. So you can see them in the command line. So I can see I have 721 posts in Java, right? 32 in Spring, 36 had the learning tag, and I can also see the frequency, right? So I can see, or pretty much I have around 300 and 250. Now it's interesting why here I have only 10 posts, and that's because this is where I took the dump of the data. They do it every 2 months, so I just took the one from July or whatever it was. And obviously that was incomplete because they do it at the middle of the month, not at the end of the month, right? But it's interesting how easy it is now to actually look at it. You'll notice that there is no graph for the standard deviation because apparently it's quite tricky to do that in the command line. But I'm going to show you a tool that does that better than Elasticat. So, big data. It's big, okay? You probably have seen this before. It's a slide that I know has been around. It's sort of a holistic view of big data system. Any of you that have worked in any type of system have used something similar. It's just that with big data, you have, well, a variance in it. There are more sources, right, or where the data comes in, and potentially the storages are different. Why? Because you have an explosion of data types, an explosion of queries that you want to apply to it, and you can not have just one store, one ultimate store, right? So here we have on your left-hand side, you have the various sources. It can be anything from social media to, network devices that are streaming the data in to your system. And this is where you start to have various flavors. You potentially can use a unstructured data, right? This would be your infinite or big data store. The easiest one is to think of it as HDFS, which would be a file system, easy to scale, not a lot of richness in it, but the idea is you can store a lot of data into it, right? But once you want to start looking at the data, this is where you're looking at potentially a different store, different format, because if you're just looking at a file, it's going to take a lot of time to look at it. So typically, you want to have some indices, you want to have some structure, so you can actually get the result in real time. If you're not looking for any structure, this is where you do batch processing. So batch processing is going to go through all the data. It takes a while, but that's the idea, right? The data is raw, so there's a lot of processing. You want to do it again, it's going to take, again, a long time. So typically, you want to have some sort of caching or some sort of results. So you can have some type of semi-structured database, right? Some type of big SQL, and then push it out to the users. So the question is, okay, where does Elasticsearch fit in here? And it's somewhere in the middle. Because it's very flexible, you can use it in various ways. You can use it even to do real-time processing because it's a real-time engine. I'm saying you can even use it because there are some different expectations between what real-time means between different users. So I'm just going to say that you can use it. I'm not saying that is a definitive answer there because, again, it depends on what people understand by that. Yes?
Fragmentation, index fragmentation. Do you guys can you schedule optimization for the indexes?
So. Okay, so that doesn't necessarily is not necessarily tied into real-time streaming.
Sure. It's just tied to
to real-time. How does that work? So, okay, a bit of a sideline, but it's a question that we get a lot. So, in terms of, there are several things you can do, especially when you deal with a lot of data and queries. So you have what we call warmers or warm-ups. So you can do the queries sort of beforehand, or think of it in this way. You can do the queries beforehand, so you can actually touch the data, so the data is hot. So when you start having queries, you can actually have the index, as you say, warmed up. We also do a lot of things such as prepare the index. So if you add more nodes, you can make sure that that data, for example, the shards are actually there before you start answering requests to that. So that also helps with the latency. But one thing that we do not do, and we're very adamant of that, we do not do re-indexing of live data automatically. What that means is if you have data in, right, and it's divided within 5 shards, 10 shards, and you say, okay, I want to scale out. Now, I don't want 5 shards, I want 10 shards. We're not going to just do that automatically for you. And the reason behind that is, thinking about Foursquares, the problem is if your system re-indexing data is an expensive operation. If you just do that automatically, it means you put a lot of stress on your cluster. If this is a live cluster, you have suddenly 100 low capacity, which means the JVM might do a garbage collection. The node might look like it's dying, and suddenly you want to move data around. But guess what? That data is actually being split up. So that's a recipe for disaster. So this is a request that we get a lot. We could do it. We could do re-indexing, which is to some degree related to fragmentation, which is, okay, I have a lot of data around, how can I partition it? But we don't do it. We want to make sure that people use it and do it and understand the implications of it. And typically, it's a lot easier to just say, okay, take the data, do re-indexing, which basically ends up with a different copy of the data, and then remove that. You can even do it without any downtime. We have what we call aliases. So you can still get requests and then do the re-indexing on a different index and then move that transparently and while the cluster is live. But we don't do that automatically without the user consent. And there's a reason for it.
You do everything else wrong there.
Well, again, that's up to the configuration. But this is one topic where we have a firm position because it's quite dangerous, and we don't think it makes sense to sacrifice reliability in this case for just a small convenience. So again, you can use it for real time. You can use it for a semi-structured database. You can even use it for the store there. put any type of data in it. And again, you can use it directly to talk to the users or to do analytics. Speaking about big data, within the ecosystem, we have good integration within Hadoop, if you're interested in that, with Cascading, Pig, Hive, HBase, MapReduce, and HDFS is actually the project that I'm working on called Elasticsearch Hadoop. So again, you can find it in GitHub and does a bunch of stuff, which means if you're using Hadoop, you can very easily read and write data transparently to Elasticsearch. So you can do queries, you can automatically do imports, you can use Hadoop to do ETL, so you can transform your data and then move that transparently to Elasticsearch. And by transparently to Elasticsearch, it means it's just like an HDFS resource. So if you're using Hive, it would be just an external table. If you're using Pig, it's just store. So you don't have to do anything. It's just one liner and then start using it. The integration already happens. We also do two interesting things, which is we're not just a store in Hadoop. We're actually mapping the native MapReduce model onto Elasticsearch, which means you have a cluster within Elasticsearch, you have a cluster within Hadoop, right? MapReduce means I have one task, I have tons of tasks being split up, work done happens in parallel, and then I do the reduce or the aggregation. Well, when you do a query using Elasticsearch, we actually do what we call input splits. So we do the input splits per sharding. So when you do a query, we actually look dynamically at the data that you're querying. You figure out how many buckets there are, how many shards there are. For each one, you're going to create an input split, which means Hadoop is going to create the same amount of tasks as shards you have within your cluster for that particular type of data. Is going to run the data in parallel. So each task is going to communicate with one node within Elasticsearch, run in parallel, and all the aggregation, all the reduce is going to happen within Hadoop as well. So the reduce and the mapping happens on the Hadoop side, but because we support the splitting, we can port that natively directly to Elasticsearch as well. So this happens for reading and for writing again as well. Plus, if you're looking, doing data collocation, so you have a cluster, right, with Elasticsearch, and you want to use the same machines that you're using for Hadoop, we actually transparently give the data to Hadoop. So Hadoop has understanding of where the data within Elasticsearch is. So then that data, that query, that task runs directly where the data is rather than potentially moving the data across. So again, this is improved performance even if you do things like virtualization. We think the best value that Elasticsearch adds to Hadoop is the fact that you have all the richness that I've showed you, and you'll see in just a bit, right? You have a search engine within Hadoop. You have analytics within Hadoop. So that's really nice. Think about it this way. Right? If you have to use MapReduce or Cascading or Pig and Hive to do full text search, okay, you can do this. You just look at the data and say, give me this pattern. But how would you do the geolocation? How would you say, give me all the document, or sorry, give me all the restaurant within 10 miles? How would you do that in MapReduce or Pig and Hive? I don't really know. That's a question that I'm leaving up to you. I would imagine it's quite difficult from what I've tried. Another benefit that you get is because you have a real-time engine, or a real-time, if you want to think about it, store that way within Hadoop, it means all your queries that you execute on the data can be redirected to Elasticsearch, which means you're going to get a big performance benefit. These are just some graphs here. We're going to publish more information on our site. This is sort of a sample application where we took all the UFO sighting reports from US. We loaded up in Hadoop, and we did a bit of counting, like, where do these things appear? And this is MapReduce's Pig and Hive, where we run these basic queries, and you can see this is where we do writing. This is where we load the data in Hadoop, and this is a scripting screen where you load the data in Hadoop and Elasticsearch as well. And as you can see, there is no real performance loss here. But in terms of reading and querying, this is where we run the same query where we say, just give me all the UFO sightings within that match square or bright or light. And you can see, MapReduce is pretty efficient. Pig and Hive, not so efficient compared to MapReduce. But if you run the same queries on Elasticsearch, you can see that, you get quite a performance benefit. And the thing here, this is not Elasticsearch returning. This is starting the Hadoop job. Hadoop connecting Elasticsearch, running the query, returning, right, and then getting the results back. Because as you've seen, the query to Elasticsearch are quite simple. All I'm signifying here is this is a total time it takes for you to create the job, start the job, move the job to Hadoop. Hadoop does the MapReduce, run the queries, returns the queries, does a reduce, and returns back. And yet, you have high benefits there. So this is just something that you could use, and we definitely would like you to play around with it. Now, talking about big data, I like just to wrap this up, by, talking about the big picture. Whenever you talk about big data, you have to talk about how do I get to that data. Right? This is data ingestion. Okay, I have a lot of data. How do I move that somewhere? Do I run some queries over it? What do I do? And there are several ways you can do about it. You can do it yourself, or there are various framework tools out there. You can use Logstash, you can use Flume, Greylog2, or you can use HDFS, which is a bit of do-it-yourself. If you're looking at Elasticsearch, there are plenty of tools that use Elasticsearch that can deal with data ingestion in Elasticsearch. But one that we recommend is Logstash. Probably because we're biased, the creator, Jordan Sissel, is part of Elasticsearch as well. And this is quite a popular tool, not just in the Ruby community, but throughout various enterprises because it's quite flexible. And it deals with logging in particular, but any type of data. So if you have tons of system, whether it's syslogd or you want to write that to HDFS, right? You have all type of systems. This is where Logstash comes in. You have tons of input, codecs, filters, outputs, just putting it out there. So it's very easy to get logging data, to transform it. You can have it in various formats, not just format in terms of file structure, but also how the data is being represented. Various mediums, where is that data stored in, where do you read it, and where we want to store it. Right? And that's a tool that manages all that so you don't have to do it yourself and uses Elasticsearch. So far, it's all nice and dandy, I was lead and hexor to show you the command line, but most folks would probably not want to grok the JSON directly. I mean, it's nice and everything, but when you're talking about visualization, probably you want to get some pretty pictures, especially if you're showing it to your manager. And this is where tools like Kibana, especially in terms of logging, make sense. This is a tool that, again, is open source. You can use it to make some sense of your data. So you can use it to drill down and zoom up, and uses Elasticsearch underneath to do all the logic. So basically, Kibana is just an UI. So let me just show you how Kibana looks like based on the same data that you've seen before. So this is the site, Kibana3, freekibana.org. You see here some pretty pictures. What it takes to download, you just download it. This setup is optional because I'm using the default, and then I'm start using it. So it looks something like this. It runs in the browser. You don't need to deploy it anywhere. It's just pure JavaScript. But it relies a lot on Elasticsearch, which means if you know Elasticsearch, you can see how it works. But at the same time, because it relies on Elasticsearch, it means it's pretty lightweight. You can very easily customize. This is just JavaScript. So let's, I still have about 10 minutes, so let's see how that works. I just started with a blank dashboard. I'm pointing out to the index that we have, stack. This is where I have all the Stack Overflow data. And now I'm going to add some rows. So let's call this options, query. And let's do some, let's say, data. All right, so now I added in, again, this is JavaScript, so I just added some rows. Let's look at the options and add something at the option. Let's add a panel. And let's add dash control. Not really interesting, but we'll do that anyway. And here, let's add a query or a, what is called string. Okay, let's make that bigger. This is what happens if you're trying to do caching. So it looks something like this. Right? And now let's add some data. By that I mean I want to add a panel that looks at the index that I've just declared above. So managing a table, let's make that 12 spam, and then here let's do sorting based on the creation date of the field, which I know it's somewhere in the database. In the data store, we expand. And the data. Okay, so let's see what we have here. So now I just created a JavaScript that looks at this index and automatically looks at the fields, right? The data is already there, so I can select it here. Let me just arrange this just a tiny bit. Make this 300. Okay. And now if I run a query such as Java, if I can select some tags, some titles, some view count, right? I get this nice representation. So what just happened? Well, I have some JavaScript, and the JavaScript just builds the queries for Elasticsearch. So this is a query, but this is a query that literally does the actual querying, and this is a panel. Now I can do the settings here, but this is interesting here. The SPY. This is a Elasticsearch query. So what you get here is what Kibana, through JavaScript, actually did. This is a JSON. Notice that it's curl, so you can actually execute it if you want. That tells you, well, you run the query using Java. So this is a query, right? And based on your UI, you selected, you did a bit of filtering, but you selected, all the posts that were available from to, and you also did no selection whatsoever in this case when it does match all, no real highlighting, and you did a creation date based on a descending. This is what I set up before. So in this case, Kibana doesn't do anything except build based on your queries to Elasticsearch. So now let's do something more interesting. Yes?
Can you show facets?
That's what I'm trying to. So now let's show some facetings. For example, let's add a time picker. Let's make this a bit bigger. Again, use creation date. Add it here at the options. Right, so I have something like this. Right, again, this is, if you can think of this panels as basically just JavaScript models, and this is something, open source, you can customize, you can move it accordingly. So we can do things here like since, and say, no, absolute. So we can say, give me all the posts from 2011, 2013, okay. But I want to visualize this, so let's do a bit of visualization as well, and add another row, let's call this graph. Yeah. Create the row, move it here a bit. Don't need this anymore. And now let's visualize some data. So one thing we could do is histograms, right? We want to know how many posts there were per month. So histogram. What do we have? Well, because a histogram requires a date, right? Creation date. Nice, I already get completion here. Okay, count. Let's make this 8. And bars, lines. Let's go with lines. Okay. 1. Always tweaking with things. Have to. Okay. Nice. Let me just make this bigger so you agree with me. No. Too big. Okay. So let's see. Java, Spring. Okay. I want to zoom in. Okay. What is this? I want to zoom out. 10. Update. Bam. And again, if you look at it, this is just some JavaScript that renders the results that come from Elasticsearch. So you can see, again, this is a curl. You notice that here is a facet. So literally this panel here says I run the query that you specify there, and I'm doing a faceting. Right? This is a pretty fine panel for histogram, so it's going to do a histogram on creation date. And you can do things like relative, which probably don't make sense. 30 days, we don't have a lot of data in 30 days, but you can say since. Right. Bam. And you can see this automatically being applied. Now, let's do something else. Let's say 13. Okay. So let's do another faceting here and add another panel, such as, okay, so I have the number of questions. I want to see the tags of them. So I'm going to pick terms, which I've showed you earlier. And doesn't have any legend whatsoever. Count 3, let's put it at 2. But let's make them, let's sort them out by pi. All right, so I'm just going to select pi, know that it's still the same facet terms. By tags, okay, 10, no legend, because we don't have enough space, and make it a donut. Okay. Okay, what do we have here? Java, object-oriented, design pattern, JavaScript. Look at it. Is yet another facet. In this case, give me the terms. And you can see here the filtering spring, right? Want to change that to, let's say, Java. Bam, I got the result. I want to say Spring and Java. Bam, you can see here Java, learning, design. And you can also do another thing, such as add another panel. Let's see the number of columns. So in this case, I would add terms, comment count. Okay, let's make that to 2. Horizontal, a legend. Okay, interesting. So now I broke this down basically per comment, so you can see this, nicely done. But you know what? Now I'm just looking at sort of one dimension here. I'm just looking at just Java stuff. I can write zoom in, zoom out, pretty dynamic. And the reason for that is everything is in real time. So when you do something in the UI, this is just a different request that goes to Elasticsearch and it returns different results. So what I could do is something like this. I want PHP, I want Ruby, I want Java, and I want Python. Right, I want to break this down, and then, and do the search. So what happens here is I'm running multiple searches. So you can see if this would actually, let me just adjust this for a bit. Right, I've minimized here the number of things. So literally from the results, I'm only looking at the fifth most. And let me just add more space to this one. So you can actually look at it. So what happens here, I'm running multiple queries. And for each query, I'm breaking it down into tags and the number of comments. So if I zoom at it, and let me just make it a bit more transparent here so we can use bars rather than lines and see how that looks like. Right, I can zoom in and see, okay, this is where I had, this is where I have, PHP is here. Probably I should add a legend as well. Hold on, let me just try that. So I can say, well, all right, so I have Python, right, appearing here. I have Java about 6. I have Ruby in red. I can zoom in. And each time I can see how relevant the questions are. So basically what I did was look for all the posts that mentioned PHP, all the posts that mentioned Ruby, all the ones that mentioned Java as well. I could add in Python, right? Do the query, and you can see how it already appears. And all the other elements here, right? Programming languages, Java, object-oriented, number of posts, they all appear at the same time, the data here as well. So you can see now I have Ruby on Rails, software evaluation, add a rating in place that appear. This is, in short, what Kibana is. Right? Just a UI, pretty flexible. It's actually started up as a demo application. We now see a lot of adoption of it because it's extremely customizable. So again, you can add in your own panels here, and this is only JavaScript. So if you want to use your own framework for it, that's fine. If you just want to use it as a model, which is actually what we recommend in some cases, you can do that as well. And if you want to learn Elasticsearch, that's a great tool because you can always see here what happens, right? This is what we call the inspector or the spyable, where you can see the actual query DSL behind it. So I can use the command line, or I can use this tool, either way. And again, everything happens real time. There is nothing particular that I have to do. And all the updates, everything happens transparently. Well, maybe I'm going to remove the points anyway. See, you get lost in this stuff. Like, What are we talking about? I don't know. Let's play around. Line fill, 2. Wow, nice. Okay. So this is what Elasticsearch is. This is what, to some degree, what it does. If you have any questions, feel free to reach to us. That's my Twitter ID, so if you have questions, I'd be more than happy to answer them. That's it for me. Thank you very much for attending.